Today we're going to talk about quadratic equations. So far we've talked about linear equation. Linear equation, if you remember, it was ax plus b equals 0. This was a form of a linear equation. Quadratic equation, on the other hand, contains a second degree variable. So x to the power 2 shows up. You still have a combination of the linear part, so you will have some form of ax to the power 2 plus the linear part. That linear part, we do not want to use a again, so bx plus c. And since it's an equation, equal to 0. A, b, and c, these are all real numbers, all real values. And we want to find out how to solve quadratic equations. There is a general way to solve it that we're going to talk about later on, but first, let's look at the zero product property. What's a zero product property? Let's assume that you have two numbers multiplied by each other. Let's look at these two boxes and numbers, and they ask you, there are two numbers multiplied by each other equal to 0. What you can say about these boxes are that at least one of these two, either this number is 0 multiplied by something like 3, or this is 0 multiplied by something on the other side like 5. For sure that you can say at least one of these two is 0. They can both be 0. 0 times 0 is still 0. So if you have two numbers like m and n multiplied by each other equal to 0, then you can say either m is 0 or n is 0. This is only true if you have 0 on the other side. For example, if you have two numbers multiplied by each other equal to 5, you cannot say this is 1, that is 5. That's not true, because you can have something like 10 times 1/2. That is still, that combination is 10 times 1/2 is 5. So this is not true, but for the other one, if you have 0 on the other side, for sure you can say one of the numbers must be 0. Okay, so how are we going to use this to solve equations? Let me show you. Let's look at this example, x squared minus 3x equal to 0. They both have the two terms, they both have an x in common. If you factor an x, what you have left from the first term is x, and from the second term, minus 3 equal to 0. Now think about this as the two boxes, as I mentioned. First box is x, second box is x minus 3, and you have it equal to 0. One of these two boxes must be 0, because there is a product of m and n, whatever m and n are. So x times x minus 3 equals 0. I can say either x is 0 or x minus 3 is 0. X is 0, it's already a solution. X minus 3 is 0. You can solve this. This is a linear equation. You can add 3 to both sides and say x must equal 3. So what is the solution set? Solution set is 0 and 3. You can check these numbers as well. Let me check it so you can see. You can replace 0 into the equation. So the check. It's not necessary to check, but you can check it. 0 squared minus 3 times 0 gives you 0. 0 times anything. And if you replace 3, 3 squared minus 3 times 3, that's 9 minus 9, it is 0. So both of these two solutions, 0 and 3, satisfy the original equation. How about if we have something like x minus 1 times 2x minus 1? It's very similar. As long as you have product of two terms, two parentheses, you can look at each parentheses and say, this is a box, that's another box, multiply by each other, equal to 0. So this is a number m, that's a number n. It's not necessary to write m and n. I just wanted to compare it to the original zero product property. So you can use that. Now you can say x minus 1 is 0, or 2x minus 1 is 0. Solve each one separately. X minus 1 is 0. You can add 1 to both sides. You will end up with x equal to 1. 2x minus 1 equal to 0. You can add 1 to both sides. You will get 2x equals 1. And divide those out by 2, x equals 1/2. So I have two solutions. So solution set is 1 and 1/2. You can write them in order 1/2 and 1 doesn't really matter. So as long as there is a product between two terms, yeah, and on the other side of the equality you have 0, you can use the zero product property. How about this equation? I have 2x times 2x minus 7 equal to negative 12. Can I say 2x equals negative 12 or 2x minus 7 equals negative 12? This is not correct. Do not do this. I wrote this example just for the purpose that you can compare and say, just because the right-hand side is, the left-hand side is factored, doesn't mean that you can use the zero product property. For the use of the zero product property, you always have to have 0 on one side. This is not correct. If you do this, you'll end up with x equal to negative 6, for example. And if you check your negative 6 as the solution, let's try negative 6. 2 times negative 6 times 2 times negative 6 minus 7. Is it equal to negative 12? 2 times negative 6 minus 7, this is negative 12 minus 7, this is minus 19. And 2 times negative 6, this is another negative 12. Negative 12 times negative 19, definitely not equal to negative 12. So this is not correct, neither the other one. Okay, you can only use the zero product property if you have a 0 on one side of the equality. There would be one way to solve this equation that we're going to discuss later on, but for the moment, we're going to just only discuss the equations that you can factor it in this form. Okay, let's talk about another type of equation, square root property. Square root property is something that you normally use and that you might have not seen it as equation form. So let's say if I ask you to fill in this box and say replace a number here, that's square it and get 9. What is that number? You might say 3. You might say, I can say negative 3 as well. There are two numbers that if you square them, they both give you 9. So what we can say is, if you're given an equation, something like x squared equals k, you can think about it as box squared equals k. And they ask you, what is this box? You can say that box is definitely square root of k. If I take a square root of 9, I will get 3. But I only get the positive value. How do I get the negative? We consider both positive and negative values. So that's plus or minus that you see as a solution. This is the solution set. It's just to consider both positive and negative, because the outcome of the square root is always positive. We want to consider both of those. So if you're given something like x squared equals 64, and they ask you to solve this equation, what would be the solution? What number squared gives you 64? Is basically the square root of 64. But you have to consider both positive and negative. You can write it this way, or this is one way. It's a shorter way of writing it, plus or minus square root of 64, which you can simplify it to plus or minus 8. Or you can say x is 8, x is negative 8. Both ways acceptable. This is acceptable as well as that one. Okay. How about x squared equal negative 4? Well, you can still do the same thing. You can say x squared equals negative 4. That means x must be square root of negative 4. But I have to consider plus or minus of that. It's not plus or minus inside the square root. It's outside the square root. So x equals plus or minus square root of negative 4. If you remember from last time, it's I times 2, which is plus or minus 2i. The solution to this equation is not a real value. It's a complex number, positive or negative 2i. You can write it as x equals 2i and x equals negative 2i. Okay, it's still the same square root property. You can use that. How about this one? 2y squared plus 6 equal to 0. I'm going to isolate the y squared so I can use the square root property. So what do? 2y squared, subtract 6 from both sides of the equation, equals negative 6. Divide both sides by 2. If I divide both sides by 2, I'll end up with y squared equals -3, and then use the square root property. What is y? Y is plus or minus square root of -3. What is that? That is y, therefore y equals plus or minus, I can write the square root of -3 as I square root of 3. Writing a negative number underneath the square root as a imaginary value. Again, you can separate them and say this is y equals I root 3 or y equals negative I root 3. Those are both two solutions to the equation. How about this one? W plus 1 squared equals 8. You might think, okay, this needs to be squared and deal with this using a quadratic equation. Well, before you use quadratic equation, think about it as, I'm going to call this whole W plus 1. I'm going to call it x. What do you have? Is x squared equals 8. How would you solve this equation using the square root property? Is you say x equals square root of 8. And I should consider plus or minus. This would be your solution. I'm going to do exactly the same thing. So what is the box? This is the W plus 1. We called it x. So x must be plus or minus square root of 8. So I can say W plus 1 must be square root of 8 plus or minus, because this was supposed to be the x. So what do I say? It's W plus 1 is either square root of 8 or W plus 1 is negative square root of 8. The two solutions. But this is a bit, needs one more step, because you have to find out what is W. We're looking for W. So W is subtract 1 from both sides. Square root of 8 minus 1. And if I subtract 1 from here, W equals negative square root of 8 minus 1. These are the two solutions to the equation. So you can still use the square root property, take a square root from both sides. Normally, you would do that. So here, I'm going to write it this way. If you have W plus 1 squared equals 8, what you do is you take a square root from both sides. Say, let's take a square root from both sides. But make sure when you take a square root from both sides, you consider plus or minus. Left side simply becomes W plus 1. Right side is plus or minus square root of 8. And to find out what is W, you subtract 1 from both sides. Say plus or minus square root of 8 minus 1. Either square root of 8 minus 1 or negative square root of 8 minus 1. You can do it this way as well. It's a shorter way of doing it. And they're all correct. Doesn't really matter. It's just to have a better understanding. Okay, how about quadratic equation with leading coefficient 1? This is something that you might have seen before. It's about factoring. If you could factor an equation and write it in two parentheses as a product of two terms, something like what we have here. If you could do this, and on the other side is 0, then you can use the zero product property to solve for the solution. So here, if I can factor this term, if I can write this as product of two parentheses, and on the other side equal to 0, then I can say either this is 0 or the other one is 0. So first we're going to deal with coefficient 1. So here, if you can factor quadratic equation with the leading coefficient 1. Leading coefficient is the coefficient of x squared. If the coefficient here is 1, then you're looking for two terms. X times x gives you the x squared. This time x times x becomes x squared. Then you're looking for two numbers to fill in these boxes. Plus. You're looking for two numbers that if you multiply them together, you want to get 2. The product of the two numbers must be 2. And if you add them together, you must get 3. Those two numbers are 1 and 2. There are multiple choices, but you have to pick the one that satisfies both property. Adding it together gives you 3. multiplying them gives you 2. We can check to see if this is a correct factoring. So let's try to distribute x plus 1 times x plus 2. Are we going to get x squared plus 3x plus 2 or not? So let's do this product just to make sure that our factoring is correct. X times x is x squared, x times 2, 2x, 1 times x is x, 1 times 2, positive 2. I have x squared, 2x plus x is 3x, and I have plus 2. It's exactly what we were given. So if you can factor a polynomial, a quadratic equation, then it's easy to solve. I have x plus 1 times x plus 2 equals 0. What are the solutions? Either this is 0 or the other one is 0. So I can say either x plus 1 is 0 or x plus 2 equals 0. X plus 1 equal to 0, you can subtract 1 from both sides, so negative 1. X plus 2 equal to 0, you can subtract 2, you'll get negative 2. So the solution set is basically negative 1 and negative 2. You can check the numbers as well. They're going to both satisfy the equation. Let's see another example. You're looking for two numbers to multiply. It gives you, okay, so think about it this way. The coefficient here is 1. So you want to have x times x to give you x squared. You want to multiply two numbers to give you negative 6. It could be 2 and 3. I'm going to write it here. This could be 2 and negative 3. It could be negative 2 and 3. It could be 1 and negative 6. It could be negative 1 and 6. These are the possibilities. This is if you multiply them together, these numbers have product of negative 6. And what if you add them together? If you add them together, 2 minus 3 is negative 1. Negative 2 plus 3 is 1. 1 minus 6, negative 5. And negative 1 plus 6 is positive 5. Which one do I want? I want the one that gives me multiplication of negative 6 and addition of negative 1. This coefficient here is negative 1. So multiplication negative 6. These are all giving me negative 6 multiplication. Addition negative 1. This is the one that I want. So the two numbers are 2 and negative 3. So x plus 2, x minus 3. These are the two factors equal to 0. And you can solve this simply by saying, okay, now I have product of two terms equal to 0. Either x plus 2 is 0 or x minus 3 is 0. So x is negative 2, x is 3. The two solution set are negative 2 and positive. You can create your own examples, by the way. Yeah, let's maybe write another example in here. Erase. Create some space here. Okay. Let's say if I can choose here. Let's say I have x squared. You can pick your own numbers. Two numbers that gives me product of negative 8. I'll pick something like 4 and negative 2, and negative 8, and 2x equal to 0. Just made it up by picking two numbers. Here. Product is negative 8. But I want their addition to be positive 2. It's not always possible. If I make this product, this addition to be 200, it's not possible to find such a numbers for the factors. So sometimes you cannot factor. I'm just gonna pick the ones at the moment that we can factor it and solve. So what are the numbers that gives you product negative 8? Negative 1, positive 8, 1, negative 8, 2, negative 4, and negative 2 and 4. How about the addition? Negative 1 and 8, if you add them together, is 7, this is negative 7, this one is negative 2, and 2. Which one do I want? Very last one. They have products with -8, and if you add them, it's +2. So what are the factors? It's x minus 2 and x plus 4. 4. I have a messy handwriting, I think. Hopefully, you'll understand the concept. Okay, x minus 2 is 0. Is x equal to 2. Either x plus 4 is 0, that is x equal to -4. These are the two solutions to the equation. Try to make up your own examples and solve it. Pick some numbers or start from the factoring and go backward. That's a good way to solve equations. Okay, I'm gonna stop here and talk about quadratic formula next time.